All right, so this is about where we left off, right? Like if we were just talking about abstraction and how functions really help facilitate abstraction. I could describe to you how to make spaghetti by being silly and saying like, okay, locate object, move limb. Imagine like, okay, move leg, move leg, move leg to walk and whatnot. But I don't need to describe how to walk to you by saying move your left foot, move your right foot, right? I don't need to because that's not how you operate. You obviously operate at a much higher level of abstraction. But I could still describe walking in that way to you. And whether you like it or not, even though, I mean, when you walk, you just walk, but you are still doing underlying tasks, you're just not really thinking about it. And we could play this game for a long time. We could work our way down quite a ways. We could start talking about contracting muscles and tendons, talking about your nervous system, your brain, your neurons firing, ion pumps. We could start going down to atomic particles, describing how to walk. There's a lot going on, really, when you think about it. But we don't, because that's ridiculous. That's not how we operate. And when we write functions, like, even though we're still, okay, I'm just walking around, I'm not thinking about all those underlying tasks, but at the end of the day, those underlying tasks and things are still getting done. When you use the print function, there's a lot going on under the hood that you didn't need to worry about, and that's a good thing, right? I didn't want to care about that, but I can still use it to do what I needed it to do. When you're writing functions, you're creating a higher level of abstraction. And when we're writing functions, we can layer this abstraction as we go. So I can write a function that solves a problem for me, and then maybe for something else I need to solve a bigger problem, so I'm going to use one of those, the function I just wrote, to help me solve a bigger problem, and so on and so on and so on. And you'll be doing that in assignment 1. Now, knowing where exactly to create, where to draw that line and say, I should make a function for this, right? I've made myself a layer of abstraction. You know, I like thinking there. There's no, I mean, you do it in your everyday lives, whether you like it or not, but you're not actively thinking about it, and you've just got like this instinct on how to do it. Taking what you already do and trying to like use it for code though, like trying to like actively think about creating abstraction, like where you should draw the line, it's not easy. It's a very difficult thing to do. It's something it's a skill all programmers are going to be developing until the day they stop programming. So when you start, and I say, oh, you're not going to be good at knowing where to draw the line for abstraction, that's not because you're bad at it, it's because it's a skill everyone's developing continuously. Always. So when I'm showing you, write a function to do this, write a function to do that, I've already told you where to draw the function. Like where to draw the line for where to write that function and what task it's supposed to do. But when you're given a problem, no one's telling you when you're given the problem, no one's telling you, here's where you draw those lines of abstraction and go fill it in. No, you kind of have to think about the whole problem, break it down, decide what should be a function, you start coding, and then you decide when coding that something else should be a function, and that's the process. At the start, I'm helping you by telling you, okay, write a function to do this. Like if you look at assignment 1, it tells you, like it follows the steps and you'll be good to go. But if I told you to do the same thing without breaking down the individual parts in order and what to do, it's a lot more difficult of a problem. Even though it's ultimately the same problem, the only help I gave you is I kind of drew those lines for you. Okay. Now here's the general format of a function. I showed you a few examples so far, but in general, this is what it looks like. It starts with def. You're defining the function. Then the name of the function. Whatever it is, you can name it whatever you want. Doesn't really matter. There's a couple of restrictions. You can name it whatever you want. Realistically, you want a good descriptive name. Then you have an open parenthesis, and then inside you have what we call the parameter list. And this is going to be where you include all of the parameters that your function's going to use. No sense including values and parameters that you're not going to use, right? So that's where you add them all. I mean, you can have a lot. Here I call them parameter 1, parameter 2, parameter 3, but likewise with any function name or variable name, you're going to want to name it something useful, more useful than parameter 1, parameter 2. But what that should be will depend on the context of what this function is doing. All right? Calculate how long it'll take you to get from point A to point B. Well, the parameter should probably be speed and distance, right? Probably call speed and distance. Calling it parameter 1, parameter 2, not that helpful. Yeah, and remember the parameters, they're just variables, but they're assigned when calling the function, instead of with like the equal sign. And then however many statements we want, we add to the function, but they're indented. Now, I did show students in lab something yesterday, and I'll show it to you all here now. If you go to settings, one recommendation I have is in the editor, change your indentation width to be 4. I think default it's 2. Set it to 4, and it's going to make it a lot more obvious what's in a function and what's not. Visually speaking, it helps, I find. When it's only 2 and you've got a couple of lines of white space in between, it can get kind of hard to tell where the line is. So here's an activity. This first one here, there's 2 activities in a row. This one and this one. The first activity is write a function, concatenate string, that will concatenate the strings and return the result. Not print the result, return the result. It shouldn't be overly crazy. We'll give you maybe a minute and a half, 2 minutes to get this one working. And of course, test it a couple times, make sure it looks like it's doing what it's supposed to do. Who wants to bravely remind everyone how you concatenate strings? What's the special thing you do? You put them together with a plus operator. There you go. Big hint for this one. Here's my working solution. Whose looks more or less exactly like this? Does anyone look interestingly different? Anyone do it a little differently? No? So what's happening? Well, line 1 runs, it just knows that a function's being defined. Line 2, it's part of the function. Line 3, it's part of the function. Line 4, there's nothing. Line 5, Line 5 calls the function concatenate string and takes the values, the arguments, hello world, jumps up to line 1 and assigns string 1, hello, and string 2 to world. Then line 2 gets executed. You concatenate the strings, put it in a variable. Line 3 gets executed, return concatenated. So we jump back to line 5. The value that was returned, which is the concatenated strings, gets put into the variable, did it work? And then I print out, did it work? Looks pretty good. Now here I only tested it once. Realistically, I'm going to want to run my code several times to make sure it does work. Testing it once is never smart. But I'm lazy. There it is once. Any questions about this code right here? Shouldn't be too scary, but if there's a question, now's the time to ask before we get moving. Because the next activity is definitely, people will find it tricky. If you find it obvious, great, good. If you don't, you're normal. But the next activity is very important. This is your first self-test. If you could do the next activity, easy peasy, and I'll give you like 4 minutes to do it. I'll give you a moment to do it. I want everyone to have a chance. And feel free to talk amongst yourselves, of course. But the next activity is a good test for yourself to see if things are clicking. Okay. Write a function called crisscross concatenation that will take 4 strings and return the concatenation of the first, third, second, and fourth. Meaning if I pass the strings A, B, C, D, those 4 separate strings, each 1 letter long, I want it to return A, C, B, D as 1 string. Make sense? First, third, second, fourth. Yeah? I want you to return the concatenation of those 4 strings, but here's the catch. You are not allowed to explicitly use the plus operator on your strings. You're not allowed to do it. Which of course is a problem because that's, like he said, that's how you concatenate strings. However, we just wrote a function that will concatenate 2 strings and return the concatenation. You're allowed to use that function, but you're not allowed to directly use the plus. But you can use the function we just wrote, concatenate strings. Here, take a few minutes to work on this one. For those of you wondering right here, this like green text, this is what you call a comment. It's a way to add like comments to your code, but the comments aren't run by Python. They're just there for another human. So I just added a comment saying what the results should be. Raise your hand if you're done. Okay, good. Raise your hand if you'll be done in like 30 more seconds. Okay. All right. Okay, clearly this worked, what I just did. But of course, I just cheated. I did exactly what I told you not to do. But as a good sanity check, it looks like I've got the right idea. Now, if you were stuck on this, and you're still stuck on this, I'm going to alter this a little bit. And we're going to work our way towards the solution. So maybe it's not a bad idea to start with a working solution and then worry about the constraints later. So I'm not allowed to use the plus, but maybe what I can do is cat 1, 2, or 1, 3. No. Okay. I just rewrote it, still breaking the rules. But I made it a little bit more verbose. And maybe my naming of the variables was a little lazy. Cat 1 underscore 1 underscore 3 is the concatenation of strings 1 and 3. And similarly, cat 2, 4 is 2 and 4. And then cat 1, 3, 2, 4 is the concatenation of those two strings. This is effectively the same functioning, like this is the same as what I just showed you. The difference is, one, I made it more verbose by putting in variables. And two, instead of concatenating all 4 in one shot, I concatenated 2 at a time, right? Now, I could have concatenated 1 and 3 and then 1, 3, and 4, or no, 1, 3, and 2, and then 1, 3, 2, 4. I could have done it in a different order. It doesn't really matter as long as the final result is string 1, string 3, string 2, string 4. Nevertheless, there's still an issue with this. The issue is I'm using the plus sign, and I'm not allowed to use the plus sign. Here, I'm using the plus sign to concatenate 2 strings, and I'm not allowed to do that. But I am allowed to use the function concatenate string. And what is the function concatenate string I wrote? Let me scroll up. What does this function do? It takes 2 strings and returns their concatenation. So wait a minute. Instead of doing this, I could just concatenate string S1, S3. Nope, that should be an S. So I'm replacing the pluses with a function call that just does the plus. And it worked. There we go. So now I wrote a function that made use of another function I wrote to solve the problem. And if we were to run this code, I'm going to zoom out one for the sake of seeing what's going on. If I were to run this cell here, and keep in mind, writing these cells independently is kind of arbitrary. I can take all this, paste here. There. I can run it all in one shot here. Let's get rid of this. Nope. I run this code. What's happening? Well, line 1, Python goes, oh, there's a function definition. Line 2, it's part of the function. Line 3, it's part of the function. Line 4, there's nothing. Line 5, oh, a new function definition called crisscross concatenation. Line 6, yeah, 7, 8, 9, they're all part of the function. Python still hasn't really done any number crunching yet. It's just making note that these functions exist. Line 10's hit, nothing happens. Line 11 is hit. We call the function crisscross concatenation take A, B, C, D. We jump up to line 5. Then we go to line 6. It's a function call. We jump to line 1. Then we do line 2, line 3. Line 3 returns to where it was called, which was line 6. Go down to line 7, go back to line 1. Line 2, line 3, return to line 7. Go to line 8. Calls line 1, the function at line 1. So we jump back to line 1. Line 2, line 3, we return to where it was called, which was line 8. Finish line 8, go to line 9, return to where that function was called, which was from line 11. Then line 12. So we're all over the place. But when in doubt, what does the code say? I realize it may not have seemed trivial, which it's not. It's complex. But if you follow all the rules we've learned so far, you won't get lost if you follow the directions. The order is 1, 2, 3, 4, 5. I'm saying the line numbers that Python looks at in the order that it looks at it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 5, 6, 1, 2, 3, 6, 7, 1, 2, 3, 7, 8, 1, 2, 3, 8, 9, 11, 12. Might sound wild, but if you just follow what's going on in the code, you'll get to what it's doing. When in doubt, what does the code say? Any questions about this, though? Because let's be honest, this was non-trivial. It was a bit of a trick. Not a trick question, but there's a click that needs to make sense about using the abstraction you made at another level of abstraction. You wrote a function to concatenate strings. Now you needed a more complex function. But to solve the more complex problem that that function was for, you made use of the other function you already wrote. Pretty good. If you found that easy, you're in great shape. If you found that hard, you're normal. This isn't trivial. But this is the direction we're headed. There's going to be a lot more of this type of stuff. But, you know, we're learning it together. So yeah, any questions before I move on? Yeah.
This is not necessarily related specifically to this, but I was just thinking, is there any way to take string 1, string 2 in that and convert it into a string? Like on line 1 in your code.
Yep.
String 1, string 2, could you say it's the number 1 and number 2, the integers?
Oh, you'd have to do it inside the function if you wanted to convert. Because right now, here's the funny thing with types in Python. What's going to happen if I do this? 1, 1, 1, 1. What's the result of this? Well, it's 4, of course. Right? Why? Well, concatenate strings just added the two things together. The order that things are added together has no impact on the final sum. So it just added everything together. But if you wanted it to be like, well, I want to make sure those things are strings. So I want to ensure they're strings. So whatever I get passed, I'm going to try to convert it to a string. If I can, good. If it's already a string, whatever, nothing changes. And if I can't, well, it's going to break, which is fine because it shouldn't work anyways. If you wanted to do that, you would have to do it within the function. That would be like maybe some of the first lines of code inside that function. Other questions? Okay. So composition. Now, when a function is called, it evaluates, the function itself gets evaluated to whatever was returned. And remember we talked about return before, where if you don't return anything, what does it return? None. So whether you like it or not, if you don't write a return for your function, tough. You get one anyways, but it just returns none, and none is a special value that means nothing. So it returns something that's nothing, which is kind of funny, but it'll be handy later. Because these function calls are evaluated to something, they're evaluated to a value, you can use them as if they were the values that they're evaluated. But of course, Python has to do all the number crunching before it can actually do any processing on it. So if you look at, we can nest function calls in statements. So here we go here. Square of sum 2, 2 plus square of sum 3, 3. Obviously, I can't add those two functions together, but I can go calculate what square of sum 2, 2 is, calculate what square of sum 3, 3 is, which is 16 and 36 respectively, and then the results can then get added together. This is A-OK, right? And we can do this with your simple math notation you've been used to since you were this big. If f of, is this even visible? Yeah. If I have f of x equals x plus 1, and g of x equals x plus 2, and I ask you, what is f of 3 plus g of 2? You could answer that question. Well, what's f of 3? Well, that's 4 plus 2, 4, it's 8. It's the same thing, just with Python syntax, not your typical math syntax that you're used to. But ultimately, it's the same idea. And I'm not trying to, when I say it's the same idea, I'm not saying something like, oh, see, it's kind of like the same idea. I'm saying it's literally the same idea. It's just different syntax. That's it. Because they're evaluated to values, I could say something like this. Square of sum, where the actual argument I'm passing is this whole function call. But realize I'm not really passing that function call as an argument to the function. No. I'm passing what that function call gets evaluated to as an argument to the function. What I mean is that would be equivalent to calling square of sum 1636. So I'm not actually passing the function call as an argument for the parameter inside the function. I'm doing the evaluation, and Python will do the evaluation first before it actually goes and calls that function. So when Python sees all that code, the order that it actually does the computing in, just for those of you that care, is it'll actually, when it looks at that line of code, square of sum 2, 2, square of sum 3, 3, when it looks at that line of code, the first thing it's going to do is actually calculate square of sum 3, 3. That'll be the first thing. Once that's done, it'll evaluate square of sum 2, 2, get back 16. Then finally, it will actually call square of sum 1636, where 16 and 36 are the results of the function calls that were nested inside of the parameter list. Yeah? Questions? Happy? Unhappy? What do you think? Yeah? Is there a reason it evaluates square of sum 3, 3 before 3? It's just the order. It always goes from the right in that way. Why? There might be a reason. There might be an underlying engineering reason as to why. I'm not aware of it. And that just goes to show how important that probably really is, that piece of trivia. I'm kind of curious. Now I kind of want to know, why does Python... Well, no, that's the right, it's not. It's right to left. Whatever. I'll look into it later because now I just want to know. Good question. We won't do it here, but as a check of your sanity, because remember what I'm always saying. What does the code say? The Python's not going to do anything that it wasn't told. And when you write the code you're writing should be very explicit. You should be very deliberate in the code you're writing because the instructions you're giving it is the instructions you want it to do. So when I always say, when in doubt, what does the code say? If I give you some code, if this was the test, I could say, here's a function, here's the input, right? What's the answer? And you should be able to go calculate it. It'll be a pain in the ass, don't get me wrong, but you could do it. Because first I could say, now in spite of Python going right to left, let's just look at the... If I were to say, what's the result of this? Well, the first thing, square of sum, that's the sum is 2, square 4. Okay, so this evaluates to 4. And then this evaluates to 4, and this evaluates to, well, this 1 squared is 1. So that's 5. So the square of sum, 4, 5. 5, that's 9. What's 9 squared? 81? It should be 81. Now I said do it pencil paper. I guess I'm just that good I can do it in my head. But you see the idea. Okay, we already talked about this, but it's important to hit. Variable scope. Parameters, which are just variables, and variables that are defined inside of a function only exist inside that function. Whether you like it or not, you can't access them. It's very intentionally hidden from you. So there, in the def Celsius to Fahrenheit, temp in Celsius, partial conversion, temp in Fahrenheit, those three variables I have no access to outside of that function. I cannot use them. And if I try, it'll yell at me. Just make sure everything looks like it's working. Okay, cool. So now I've got temp in Celsius. Print temp in Celsius. If I try to run it, it's going to say it's not defined. And then you as the programmer goes, yes, it is. It's right there. I'm looking right at it. It's defined inside that function only. So this function is happy to use it. But nowhere else in the code can I access it. Not outside the function and not inside some other function. It only exists inside that one function. Now, if I had a variable like this, it will know, because it just so happens that the variable name outside the function and the variable name inside the function is the same. Okay, yeah, it'll work. But that's only by luck. That's just a coincidence, right? If I go back to something like this, well, it'll still work because it's in the runtime. But if I restart the runtime, it won't. What the hell's that? It doesn't know. This might seem annoying, but this is actually a really good thing because it hides. If I really wanted to access some information from inside that function, it should have been returned. If I need the information, if you're a function and I need some information from you, you got to give it back to me. If there's a reason it wasn't returned and I'm trying to access data from inside that function, why am I doing that? Something's gone wrong. You shouldn't be doing this. This is weird. We use the argument, like the parameters in the return as a way to pass information around. But as soon as you try to access information through another way, you're introducing issues here. And Python won't even let you do it. There are ways where you can kind of do it that we could talk about later, perhaps. But in general, it's not a good thing. You don't want that to happen. And this is a good thing because think of the print function. There's probably several variables inside that print function. But the print function has a purpose. It's a well-designed function. It's got an important purpose. It prints stuff out. That's its role. Celsius to Fahrenheit has a very important function. It converts Celsius to Fahrenheit. How does it do it? I don't care. If I want to use that function, I just need it to actually do what it does. I don't care. So when I call it, it gives me back the result. I should be happy. If there's ever some function where like, oh, I know I want more information from it, why? Maybe that function wasn't well thought out. Maybe that shouldn't have been a function designed that way. If you really need that information from inside of it and you couldn't return it for some reason, what's going on? That's an indication of what you might call stinky code, where in and of itself, it's not really a problem, but it's a sign of a bigger underlying issue. It's stinky, right? Sure, it stinks, but what's causing the stink, right? Is the code poorly designed, right? At this stage, concepts like well-designed code is hard to really understand until you start writing bigger and bigger and bigger chunks of like bigger programs to see how you would have a chance to kind of lay it all out. Right now, it's all very hypothetical, right? But once you like work on assignment 1, you'll see. So scope. Trying to run, it'll create an issue. Yeah, here's a better example. There. Look at what this code is doing. I changed it a little bit. It's Celsius to Fahrenheit. And look, on line 8, I'm printing out temp in Fahrenheit, which of course is a variable used and defined on line 3. But it's also used and defined on line 6. And that's the line that outside the function actually cares about. So when I print out temp in Fahrenheit, I see what it was assigned to on line 6. Temp in Fahrenheit, and then the temp in Fahrenheit inside the function, they have the same name, but as far as the computer's concerned, they're entirely different. They're separate. It's not going like, oh, it's the same variable, but inside this scope, I know it means this. No, they are separate things. There is a way to set variable to have global scope, which means you can define it outside the function and things inside the function can use it. In practice, don't do this. As soon as I see someone's code and I see things defined globally, I go, okay, I know I'm in for some trouble looking at this code. I know I don't want to look at this code anymore. There are, of course, exceptions to these rules, but almost always I see something like that and I go, that's not a good sign. Import. You've all done this a bunch of times already. Like I was saying, Python, when you load up Python, Python provides like the standard library, a bunch of built-in functions already written for you that you don't need to write and you can use, like print, like input, like type, like square root function. There's a lot. In fact, there are so many that it becomes impractical. When you load up Python, it's not a good idea to load up all of the possible functions that you might want to use that they do provide to you for free. What it does is it loads up a minimal set of functions. And then if you really need them, you say, okay, and I want the ones from the math library. Library meaning, or module, meaning where those functions are actually stored. So, for example, all of the math functions, your square root function, for example, it exists, it's written in the math module. When you load up Python for the first time, Python gives it to you for free, but it's not loaded up yet. If I try to use it, it won't work. Because there was no sense in loading it up. A lot of programs you're going to use, you're going to write, you're not going to need the square root function. So why load it up? If you do need it, you go get it. Unfortunately, it's easy to get. You import math. So just to prove my point, sqrt, it does exist. The square root of 4, I run it, it's going to say it doesn't exist. That's because I need to import it. So I say import math, because that's where it exists. Then I say math dot square root. So I imported math, and then from math, use the square root function. And now it's happy. Yeah, scope. This scope applies here too. Scope doesn't just apply to variables and functions. It applies to functions in different chunks of code. Like there is a math module, which is a whole Python script that's entirely separate from your code. You can go look at it if you want. Let's see if I can get it real quick, just for the sake of showing you. Ignore what the code actually is right now. There. This literally here, this right here, oh no, it's just an interface. All right, well this is sad. You don't actually get to see the code itself. But point remains, it does actually exist somewhere on your computer, or here in Colab on Google's computers. You import it, now it's available for you to use. But unless you import it, Python, because it's outside of scope, it doesn't know it exists until we explicitly do it. The square root already exists. Fortunately, you don't import math. Yeah, within the math module is many common mathematical functions you might like. But listen very carefully. This is a joke in programming. Read the docs. Don't assume the function works the way you think it works. All right? If I want to go and use the sine function, I better go read it. So I'm going to go here. I'm just going to control F sine. There's a sine. Let's go to the next. Regular sine. If I were to type in sine, you're like, oh, that just calculates the sine. But if I read the docs, which look, isn't hard, it's a tiny little sentence. It says, okay, yeah, returns the sine of x, radians. If I didn't read that, what would you assume this returns the sine of? Radians or degrees? Degrees. Yeah, you'd be wrong. So let's play out two scenarios, okay? Scenario number one. You write math.sine, you hit run, it gives you a number, you assume it's correct because I can't remember trig crap, right? So I hit run, it gives me a number, I'm like, yeah, okay, good, this is great, you know, this is very important code. But when I incorporate it into a bigger piece of code, it doesn't work, right? For some reason, I'm getting wrong answers, and I don't understand why. And of course, that sine is one line of code of a bigger chunk of code that I wrote, and it's not working, and I don't know where the issue is, what's going on. I beat my head against the keyboard for days and days and days. I can't find it out, and I'm in big trouble. Or, scenario number two, I want to use the sine. I should read the docs first. Oh, radians. Oh, okay. Which of the two scenarios is better? Second, of course. It was a stupid question. That's the joke. That's also the joke on the Moodle thing, right? Reading the documentation can, or no, not reading the documentation. What does the joke actually say? I'm going to get it wrong. I've ruined the joke now. There you go. 6 hours of debugging can save you a whopping 5 minutes of reading the documentation. In this case, 5 seconds of reading documentation. Read the docs. Now, if you're thinking, great, radians, who the heck works with radians? Well, everything in the universe does, whether you like it or not. But fortunately, if you look 2 functions below, you see these two right here. Convert from radians to degrees, degrees to radians. Yay. So there's also a built-in function for doing that really easy. Thank God. You got to remember, I said this in one of the labs, so you may have heard me say it already. I know you see radians, you're like, that's annoying. Why didn't it go with degrees? Everyone likes degrees. Well, the funny thing with degrees is, does anyone know why there's 360 degrees in a circle? Because some people 5,000 years ago said so. Why is there not 361 degrees? Because people 5,000 years ago said so, whether you like it or not. You want to know why radians are radians? Because it's related to a property of the circle. It doesn't, no one said 360 degrees. Why? Just it is. Radians? Well, it's because it's like the ratio of the radius and the curve and the, right? One is a fundamental property of things within our universe. The other is someone somewhere said so. Why? Because they did. It was 5,000 years ago. We're not going back now. So I know you like your degrees, but humans are weird. If aliens came to Earth, they'd look at degrees and go, what? Degrees? 360? Why? Right? If they saw radians, they'd be like, yeah, checks out. Makes sense. Right? Cool. Oops. Import math. Now comments, the last thing. If you ever have a line of code that's a little complex, first of all, your code should be self-descriptive. But let's say you see a line of code like this and you're like, how am I going to describe that anymore in terms of self-descriptive code? I mean, that's just Euclidean distance. A lot of people might look at that and recognize it. But ultimately, when in doubt, if you're like, if this is a little unclear, if this is potentially unclear, add a comment. A comment, you start the line with the little hash sign, and then you write in English what it's going to do. Python will entirely skip that line. It doesn't exist as far as it's concerned. That's for you, a human. So now I can look at that line of code. Oh, yeah, it's the Euclidean distance between 2 points. Great. All right, there we are. See some of you later in lab today. And remember, if any of you are stuck, if you need help with something, come to office hours. It's been awfully lonely. Come visit me.